हेलो।
हाँ सर।
हाँ हेलो निकी जी,
हाँ
गुड
नमस्कार सर।
आफ्टरनून। कैसे हैं आ रही आवाज आ रही है?
आ रही है आवाज आ रही है?
हाँ मतलब बोथ वे कम्युनिकेशन है ना, ठीक है।
हाँ जी हाँ जी, दोनों साइड से।
ठीक 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 ठीक। तो मैं शेयर कर देता हूँ स्क्रीन पहले, है ना।
अभी थोड़ा मैं कुछ बोल देता हूँ जरा।
जी जी जी।
सभी प्रतिभागियों को दोपहर के बाद का नमस्कार। आज हमारे कार्यशाला के दूसरे दिन का दूसरा सत्र शुरू होने जा रहा है, जिसमें डॉक्टर नरेंद्र सिंह प्रसिद्ध वैज्ञानिक हैं, एरीज में साइंटिस्ट थी। उनके 50 से ऊपर कम से कम रिसर्च पेपर पब्लिश्ड हैं और कई किताबें भी उनकी पब्लिश्ड हैं। कई बच्चों को उनको पीएचडी भी करा दी है। अब मैं उनको आमंत्रित करता हूँ कि वे अपने व्याख्यानों से इस कार्यशाला में जितने भी प्रतिभागी हैं उनको लाभान्वित करें। डॉक्टर नरेंद्र,
बहुत बहुत धन्यवाद निकी जी। मुझे लगता है आपके यूट्यूब से भी कुछ कनेक्ट होंगे बच्चे ना।
यस सर।
ओके। तो मैं पहले स्क्रीन शेयर कर लेता हूँ, है ना। हाँ निकी जी, आ रही है ना स्क्रीन विजिबल?
हाँ सर। हाँ जी हाँ।
ओके, थैंक यू। सबसे पहले तो मैं नेगी जी का फिर से धन्यवाद करना चाहूँगा, क्योंकि कुछ अभी दिसंबर में भी इनके यहाँ आपके यहाँ जो प्रोग्राम था उसमें भी आपने हमें अवसर दिया था छात्रों से बात करने का। और पुनः मैं आपका फिर से ये नन्ही परी सीमांत इंजीनियरिंग कॉलेज में आप जो कार्यक्रम अभी ऑनलाइन वर्कशॉप ऑन मिस्ट्री ऑफ फिजिक्स पे करा रहे हैं, इसमें मुझे आमंत्रित करने के लिए पुनः आपका धन्यवाद करूँगा। तो विषय इस बार जो हमने रखा है वो है एयर पोल्यूशन एंड क्लाइमेट चेंज। मैंने एक छोटी सा वीडियो भी रखा है यहाँ की फैसिलिटीज पे, जैसा कि मोस्टली आपका ये था कि हैंड्स ऑन एक्सपेरिमेंट टाइप या कुछ चीजें बच्चे देख पाए, तो वो मैंने अंत में रखा है। तो अंत में उनको थोड़ा सा ये भी दिखा देंगे। So I'll be basically talking about air pollution and climate change. So air pollution, as we all understand, is a burning issue nowadays. And whenever we talk about the, sort of air quality and all sort of diseases which are being, nowadays considered to be spread because of air pollution or air quality degradation. So air pollution and climate change, these are two well, connected topics and complementary to each other. So to some extent, people have now started believing that due to the man-made activities or the pollution that we are creating, basically the man-made activities is somehow in some or the other way trying to contribute to the climate change as well. So I'll just start with a brief review of climate change first, and then we'll go by subsequently by the the process and the sort of pollutants and then climate change issues. So this is basically an overview. So air pollution and then how these air pollutions are being produced from the anthropogenic activities. Then of course, what is the global status of the this air pollution, whether it is of the gaseous form or the particulate matter. Then of course, what are the impacts on human health mainly, and how it is damaging the environment. Then of course, I'll be dealing little bit about this climate change issue, and then of course how global warming is associated with the climate change. And then Himalaya, basically, since we are very, sort of closely attached, and we have been grown up in Himalayan region, so we have a lot of affection and attachment towards our Himalayan region. So I'll be dealing a little bit about climate change issues at the end, which are of great concern to the Himalayan region. and then what are the challenges, and then what could be the mitigation strategies as far as the climate change is concerned or the calamities are concerned. So now, what is air pollution? The simplest definition of the air pollution could be that anything which is mixed in the atmosphere, whether it is a gaseous form or in the particulate form, and which can cause potential damage to the living organism, whether it is a vegetation or human being or any other living things of our ecosystem, and which can and also can cause damage to the environment, which is consisting of all spheres of life. Or the another simplest definition, we can say that a condition when we talk about the air pollution in which the quality of air is degraded significantly, and that is because of the harmful substances which may be again uh, gaseous or particulate matter. Particulate matter is one example of that. And then of course the third definition what we can see is that it is anything which is invisible or visible in the atmosphere. It may be again gas or particle, which is not the part of the original composition of the atmosphere, because nature has given us an atmosphere initially, which is mainly consisting of nitrogen, oxygen, and we say, 78% nitrogen, 21% oxygen, and 1% other, gases, say inert gases, or then trace gases, or whatever material available in the atmosphere in the mixed form. Basically that was the original composition. But if there is change in that original composition, so it means there is something which is being emitted or emanated into the atmosphere, which is causing basically the changes in the original composition. So the classification can be like this. There are two kinds of air pollutants, which basically one is natural and other is anthropogenic. So again, anthropogenic, natural, basically the example of the natural could be sea salt spray, like which is mixed from the tides and the waves of the atmosphere. When they rise up, they break, and then air passes over it, mixes it with the air, and then take into the atmosphere. So that is, we call that sea salt spray, because the amount of the salt is much in the oceans or the sea, so that get mixed. We call that sea salt spray. And then second example could be the the pollutants or the gases that are emitted in the volcanic eruptions. That is also again natural, part of the natural activity, which is mixed into the atmosphere. And one more example that we can take is basically the desert dust. The desert dust, basically, desert dust is basically blown by the air or the storms or the strong winds into the atmosphere. And we call that wind blown dust. So these are some of the examples of the natural emissions, or the naturally emitted or produced pollutants in the atmosphere. Whereas the anthropogenic pollutants are basically nothing but that which is the resulting from the man-made activities, whether any sort of development we talk about, the industrial revolution, or the all sort of emissions through vehicles or industries, which are not of the natural origin, but created by the human being. So we call them anthropogenic emission, and these are of two types basically. One is indoor and other is outdoor. Indoor emission is basically that which is traditionally in the villages, like we are using the traditional stoves or chulha, we call it, and we burn wood, and then that produce a lot of black carbon and other gases, carbon monoxide, etc., inside the house itself. And that is indoor pollution, which is also very dangerous for human being, and it takes a lot of toll to the life. And then again, outdoor pollutants, again, which are exposed or expelled into the atmosphere in the open sky, we call that outdoor pollutants. So these are some the major examples. You can see that wood burning, basically the traditional chulhas that we are having inside house. Then forest fires, of course, in summer we see a lot of forest fires, not only in India but across the globe. Then diesel engine, because it is basically not the complete combustion of the fuel, so it produces more sort of black carbon into the atmosphere. And we have millions of the vehicles over the globe which are producing every hour a lot of these emissions from the diesel. Then industry, of course, agricultural burning. You can say that to clean our fields, after the crop is taken, farmers usually burn their crop residuals, so that also produce a lot of tons of carbon monoxide and other things, other pollutants, black carbon mainly, or particulate matter of the size, say PM 2.5 or even larger than that, into the atmosphere. And non-road vehicles, of course, like we have a lot of developmental activities. You can see a JCB here in the picture. So most of the time around the year, you can see that some of the construction activities are going, for the sake of the development, and they also produce huge amount of basically run by diesel. So again, pollutants in the atmosphere. And you can see the car and the buses, the other vehicles, two-wheelers also, they produce a lot of emanate a lot of sulfur, elements of the sulfurs and nitrogen into the atmosphere. So these are the simplest examples you can see. Now the 5 major pollutants that are present in the atmosphere are carbon monoxide, sulfur dioxide, nitrogen dioxide, particulate matter, and ground level ozone. So when we talk about ozone, so ozone again has two different characteristics in different regions of the atmosphere. If the ozone is present in that stratosphere, that is good for human being or human life or all living beings, because it basically stops ultraviolet radiation in the upper atmosphere itself. Whereas if the amount of the ozone increases in the lower atmosphere or the surface, on the surface of the earth, it is dangerous or detrimental to the human being or living beings, and as well as for the vegetation as well. So this carbon monoxide is produced during the biomass burning, huge amount of carbon monoxide. The oxides of sulfur and nitrogen are produced through the vehicular emissions or the industrial emissions by burning different chemicals for energy. And then of course these are of oxides are of the gaseous, when it combines with in the presence of the sun or with the chemically reactive species, they form nitrogen dioxide, sulfur dioxide, etc. Whereas the particulate matters are of different origin present in the atmosphere, which are having the size less than, say, of 2.5 micron or of that order. So this is a typical picture where you can understand that what are these pollutants, again of two types, primary pollutants and the secondary pollutants. So the primary pollutants are basically emitted directly from the identifiable sources, the sources that we can identify, like for example, the fossil fuel consumption in the vehicles or the industrial emission. These are direct sources that we can see. But what forms as a result of the first level emission or the primary emission of these pollutants in the second level is called the secondary pollutants. So for example, the primary pollutants, you can see that carbon monoxide, carbon dioxide, nitrogen dioxide, nitrous oxide, and most of the hydrocarbons or volatile organic compounds, we call them VOCs, volatile organic compounds, which is coming from the naturally through the forest and all sort of the vegetations. So these are the primary sources. But when in the presence of the sun, they undergo photochemical reactions, and then they form the secondary pollutants. For example, you can see here the H2SO4, HNO3, which are very intense or dangerous acids. And sometimes when as a result of these interaction of the primary pollutant, they form the secondary pollutants. They become so detrimental that many places witness this acid rain, we call. So generally in villages, when we hear people talking that whenever it is raining first time after a long period, we should not be exposed to that rain, because it brings a lot of as a chemical reaction, a lot of acids on the surface of the earth, and which is not good for any living being or animal. So this is one example that how man-made activities have raised the background level of pollutants itself. So hello.
Yes, sir.
Am I audible now? Actually, there
Yes,
was
sir,
some
yes, sir.
interrupt. Sorry for this interruption. There was some problem in internet at our end. So okay, so I was just discussing about the one example of pre-lockdown and post-lockdown situations as a result of what we call example of man-made activities, effect of man-made activities, and then effect of lockdown basically on the man-made activities. You can see that PM 2.5 is going up to say around 140 microgram per meter cube, whereas immediately after the lockdown, it has come up to say 80 microgram per meter cube. There are of course some peaks, but they are from different places, so representing the local influence of a particular emission in that region. So, but still we can see that 40 to 50% of pollutants have reduced immediately after the impose of this lockdown. So this shows that how much amount of pollutants human or man-made activities are adding into the atmosphere. So we can say that if there would have been no vehicle for running for the year or for a day, you can say that This would be the background level in that sense, and the international standards says that your air quality index has to be somewhere between 15 to was in upper limit 15 to 100. If we talk about air quality index, which is basically of not of one particular species, but it includes all sort of the gases, and it includes all uh, we can say that particulate matter and all sort of emissions which are present due to man-made activities into the atmosphere. So this is how we can understand that what are the influence of the man-made activities, whether it is outdoor or indoor. Both way we are trying to contribute in that sense. Now, yeah. So if you see that what is the globally averaged CO2 which is present in dry air of Mauna Loa, which is a location in Hawaii in the South Pole, where it is considered that which is very away from the man-made activities, and it is a site where regular observations of the carbon dioxide is measured are made. So carbon dioxide is the major pollutants, if you see, which is basically creating global warming, because carbon dioxide is considered to be the main agent for global warming, because it traps all sort of outgoing long wave radiation and increases the temperature of the air near surface. So you can see that it has been continuously, if this you see the 1960s measurements, it is continuously increasing, and it is reached by the data available by 2010. It has reached from around less than around 300 parts per million to around 400 parts per million. So 100 ppm has been increased within say 40 years, 1960 to 50 years, you can say. So these are global warming trends, and the rate is also not that fluctuating. Here you can say that rate of increase is consistent. So in the last few decades, starting after 2000 to 2010, or even beyond that, we can see that the rate of increase of CO2 per year is consistent. I mean, it's not going down. There is consistency. If you see here, it is consistency in the increase. Similarly, if you see, methane is also one of the greenhouse gases. It is also increasing consistently. However, it is not that steep, but the rate of change are also consistent, mostly positive. And then third, if you see the oxides of nitrogen, parts per billion, they are also consistently increasing, because this is the emission from vehicles and industries mainly. And this is again showing consistent rate of change is consistent over past few decades. Here around after 2000, mostly in the last in the beginning of this century, you can say that nitrogen dioxide is also consistently increasing. So these are the, some alarming situations that man-made activities is playing significant role in contributing the emissions in the atmosphere and polluting the air. So if you see the hazards which are caused by these increased level of the pollutants in the atmosphere, we can see that most of the health pollutants are closely associated with mortality, which are whether premature mortality or any sort of the mortality related to the lungs. You can see that hair damage, it causes eye-end membrane irritations, it causes respiratory diseases also, and responsible factors are ozone, particulate matter, sulfur dioxide, etc. And liver, spleen, and blood damage it also creates. So there are number of factors which are responsible for all sort of the diseases or to destroy the human human organs, whether it is related to the respiratory or related to the bones, whether there are radiations also available in the atmosphere. Then of course sulfur dioxide creates fatigue, headache, anxiety. And so from this picture we can understand that it not only affects a single thing, but nervous system, cardiovascular damage, intestine damage, reproductive damage, skin damage, all sort of effects are created by air pollution. So one example here, you can see that this is a healthy lung and this is a damaged lung. you can see, and this is basically around 30 to 40% of the cases of the asthma and 20 to 30% of the respiratory diseases may be linked to the air pollution, because whether it is ozone goes into the lungs, it also damages your lungs, or particulate matter goes into the lungs, that also harms your lungs. So these are the example that how healthy and damaged lungs looks like. Now, if you see the global burden of the air pollution, that how many deaths are caused by the globally by the air pollution, you can see here that the minimum deaths which are caused by the air pollution in a country starts from 16,000. This is the minimum level every year. So 16,000 at least are any country on the globe, they are bound to go the damage of this much amount of human life, you can say that, or this much number. And in India, in the context of India, China, if you see, so it is more than, in case of India, if you see the due to outdoor air pollution, China is have witnessed 8,52,000 deaths in 2017. Whereas due to the indoor pollution, which is basically household burning, wood burning inside the house, or all sort of other pollutants, it is 2,71,000 deaths in China. But in India, if you see that household is just, more than or close to double, you can say, 4,82,000 inside. This implies that still many people in India or the rural areas are still using the traditional way of burning woods and for their cooking requirements. And if you see that outdoor pollutants have killed around 6,73,000 people. So 92% of the world's population lives in areas where WHO quality guidelines are exceeded. Basically, hardly 8% of the places over the globe are such that who are at least meeting the air quality standards. Say, as I say that if your particulate matter concentration should be less than say 50 microgram per meter cube or 40 microgram per meter cube. So only 8 to 7 to 8% places are where which can meet air quality standards. So this is a global picture, and air pollution is ranked 5th as a risk factor. This is the 5th. It is the 5th in the ranking of the life-taking, diseases or the processes that such an important factor if we talk about the impact of the air pollution on the human health. This is the aspect of the human health. Now, another thing that caused by the air pollution basically is the visibility degradation from the aerosols. We call them the suspended particles, any sort of the particles in the, whether gaseous or liquid, gaseous, liquid or solid particles in the atmosphere, which are present in the form of the pollutants. They basically degrade the visibility also. These 4 pictures are from the same places. If you see here, you can see when the your total suspended particles are in the atmosphere are 7.6 microgram per meter cube, then you are able to see the mountains in the background which are covered with the snow. When it becomes just double, you can see around 12 microgram per meter cube, you can see that visibility has reduced. You are not able to see the last peak of the mountain. But when it becomes 3 times, you again, the picture has become quite hazy and you are not even able to see the mountain in the background. However, the foreground mountains you are able to see. But when it became around 10 times, you can say 65 microgram per meter cube, the mountains have completely disappeared. So this is another effect on the atmosphere which pollutants usually create. And in winter, if you see in the plain regions, you can't see anything. There is a thick layer of the pollutants. We call that a smog. Pollution plus smog form. Water droplet plus smog due to the various activities form the smog. And it is all plain regions for say about 1 to 2 months are completely under the cover of this smog, which is very, very dangerous. Now, acid precipitation is another example. You can see that the secondary formation of the particles basically create acid rain. And as we discussed, that fossil fuel burning releases tons of the sulfur and nitrogen in the atmosphere. And these pollutants, while reacting with the water, form sulfuric acid or nitric acid. And these sulfuric and nitric acid are very strong and cause damage to the vegetation. So you can see the example. Due to the acid rain, the fresh leaf used to be like this, and you can see that the damage, acid rain has damaged immediately after the rain in the forest, the burn the leaves of the trees. And you can see how trees becomes whenever there is a acid rain. So it has many other effects, like it damages and melt away stone statues and the structures which are basically of historical importance. And then it changes the pH values of the water, basically, which is fresh water in the lakes and the rivers and used for the drinking purposes. And then kills the aquatic life, whether be it a fish or any other aquatic life. So these are the effects of the air pollution. Basically, it has a multi-dimensional effects. And now the impact of the tropospheric ozone, basically the ozone at the surface. So I mean, if you say that the permissible limit of the ozone at the surface has to be somewhere between 50 to 70 ppb, parts per billion, but when it crosses 200 or even higher than that, so you can see that it affects the crop also. So this is actually a lab experiment where you can see that the same variety of the wheat is exposed to the fresh air and other is exposed to the polluted air, basically unfiltered air, which is having ozone. So the growth you can see in the same time, the wheat crop, which was wheat plants which were supplied filtered air, are showing much better growth than the unfiltered air. So these are the impact, and you can see that how this ozone basically affects the leaves of the plants. You can see that they have damage there. You can see the yellowish patches. So these are caused by the ozone in the troposphere. So as I told that ozone in the troposphere is bad, whereas ozone in the stratosphere is good. So again, another very important phenomenon for which scientists from the Max Planck were awarded Nobel Prize on the invention of this ozone hole over the Antarctic region. You can see that ozone, this was observed in October 70, 71, 72. These were the observations. So red, more widespread red color means the ozone concentration is high, but then it becomes blue. So it means ozone concentration is decreasing. So this is how we, I mean, not actually the whole, but it is actually the reduction in the amount of the ozone present in the atmosphere, in the stratosphere, which protects us from harmful radiation. So when this ozone somehow is destroyed through chemical reactions, and chemical reactions with a particular chemical, for example, I mean, this hole was mainly created by the CFCs, chlorofluorocarbons, basically, that were used in the refrigeration process to freeze the, as a coolant, you can say, and those gases were emitted into the atmosphere for a long time in 70s and 80s. And as a result, when some observations were made after 2001, 2, 3, and 4, it was observed that the previous observations, say 20, 30 years ago, were quite different from the latest observations in the beginning of the century. And you can see that the ozone has been reduced to up to 120 Dobson units, which used to be around, say, 500 Dobson units. So which is a significant decrease in the ozone, the presence of the ozone in the stratosphere. So that is another impact of the pollutants. And these pollutants are basically man-made pollutants, because CFCs were invented by human beings. They were used for refrigeration. They were emitted into the atmosphere, and which were carried towards, I mean, by the winds from tropics or the regions where people live towards the pole. And it affected the southern pole to the maximum extent. Again, you can see that when Kyoto Protocol in 1997 came into being and became effective after 2005, you can see that there has been, when these all chemicals were banned to be used in the refrigeration process. So then again, to some extent, however, still the amount at the southern pole is not that much increased, but of course it is increasing. It is moving towards positive side. There is slight change in, slight improvement in the ozone, but still it has already caused severe damage to the ozone layer in the atmosphere. That's why people who visit towards southern poles or in the scientific expeditions, or if you go towards the north pole, it is always advised that we are not exposed much to the sun, because it immediately causes sunburn. It burns your skin. Even we have observed, experienced this in Canada. If you go to the northmost Canada, towards Montreal and even Quebec region, in the daytime, people usually avoid to be in the sun, because it is having more amount of ultraviolet radiation in the visible light. So that causes your skin damages and sunburn. So now these were actually a sort of review and some sort of flavor how air pollution or air is being polluted by the man-made activities and what are the impacts. So the impacts are not only on the human ecosystem or say living beings, but it also have long-term impact on the climate change, because consistent emission of the carbon dioxide through man-made activities is increasing the temperature of the globe, and we call that global warming. So, and if we see the changes in the climate, means climate is basically a long-term aggregate weather is climate. What we expect tomorrow is climate, and what we see today is weather. So if in long term, say epoch in the climate change, scientists usually consider an epoch of 30 years in climate change. If you talk about the climate change, we cannot say that from one year to the other year the temperature have changed drastically. So it is climate change. Climate change is basically taken over a period of the 30 years, that the temperature which was 30 years, or in the average temperature in 30 years, has another 30 years, that parameter has that parameter changed drastically, or is that observable parameter is witnessing something high or low values from the mean values. So we call that climate change. So basically the long term, the measurable parameter, if they show or display changes in long-term basis in the measurable parameters, we call that climate change. Or climatic parameters are mainly your temperature and rainfall, which are directly having concern to the human activities. So now people have started believing that climate change is happening. I mean, nobody can say today that climate change is not happening, because there was very serious debate on these issues in 80s, that many scientists disagreed that climate change is not happening. It is a geological scale, phenomenon of geological scale, which is basically of 10 to 12,000. So it changes in 10,000 to 12,000. But then, of course, the climate scientists or the atmospheric scientists or the meteorologists have great concern that they were observing the changes in the trends of rainfall, extreme weather events, drought events, and extreme high temperature episodes. Winter temperature also going up. So then, a panel was established in 1988. We call that IPCC. They were awarded Nobel Prize for this. So for this, that they identified that whatever climate change is happening because of the man-made activities. So human being is responsible for the climate change today, which we are witnessing or we are seeing. So warming of the climate system is warming, which is unequivocal, means it's everywhere. It is not at one place or the other. Maybe at some places the rate of warming is less, and other places it may be high, but it is unequivocal. It cannot be avoided. And as is now evident from the observations of the increase in global average air and ocean temperatures, widespread melting of snow and ice, rising global average sea levels. So this is basically the IPCC finding in 2007, where for we were awarded Nobel Prize. Now here you can say this is the projection. This is projection for you can say by the end of the century, 2090 to 2099. If you see the temperature which were observed in the beginning of this century, taking the base of that, all sort of climate models, global climate models were used for this under different scenarios, taking all sort of economic activities into picture, taking population into account, and then it was projected. So here you can see the projections. Projections means the lowest temperature here is 0, where you cannot see that there is not any place which is showing this gray color, means there is not even a single place on the globe which will not witness the rise in the temperature by the end of this century, or which is not witnessing it even at the moment. And it is going up to say 6.5 to 7.5 degrees Celsius. So here at the North Pole, if you see, the temperatures are expected to rise by 6 to 7 degrees. And if you see the Indian context here in the Himalaya is somewhere here in this picture. If you see, even over entire Indian region, starting from 3.5 to 5 degrees Celsius or 4.5 degrees Celsius rise in the temperature is expected over almost all locations in India, starting from 3 to 5 degrees Celsius. And of course, globe is warming. So this red color is not a sign of relief, but of course, it's a sign of calamities, or say we are going to see many more extreme weather events in future. So this is a alarming situation, global scenario if you talk about. So now I'll come to some basics of climate system. So our climate system is basically consisting of all sort of sphere. We cannot take into all on different spheres, say in individualistically, or you can say in individual. So we have to understand climate system in totality, whether it is a hydrosphere, which is basically your rivers and lakes, or the fresh water present on the surface of the water which is flowing, and whether it is atmosphere, because atmosphere is ultimately responsible for responding or interacting with the solar radiation in different ways, forming secondary pollutants and all sort of activities which are related to the radiation are taking place in the atmosphere. So we cannot see that atmosphere has to be studied individually. And again, if we talk about say volcanic activities, also these are also part of our biosphere. So biosphere, cryosphere, hydrosphere, and atmosphere, all four has to be studied together. So these are all connected, and source of all these activities on the surface of the earth is you can say sun. यहाँ पे रख दो, 4 बजे के बाद जाना. We can say that we have to understand the climate system in totality. So we have human influences, we have natural activities, we have and then they interact together, and then of course we can see the results in the form of the rising sea level, melting of the glaciers, etc. So sun is the source of all sort of energy on the surface of the earth. Now basically these are the if you talk about the science of the this global warming, or say climate change, whatever solar radiation is coming from the surface from the sun is basically coming in the various wavelengths, starting from the radio wave to gamma rays. But the solar radiation that reaches on the surface of the earth is only visible light, and this visible light basically is trapped by these is absorbed by the various objects on the surface of the earth, and then re-radiated back into the outgoing long wave radiation, which is trapped by the greenhouse gases, so-called CO2, methane, and sometimes water vapor also, and that increase the temperature of the surface of the earth. So this is what we call global warming. And then, of course, everything happens in the troposphere itself, as we have been discussing, that ozone is in somewhere in that stratosphere, which prevents us from the various harmful radiations which are coming from the sun, mainly ultraviolet radiation. Now, if you can see that the global rise in the temperature over 1850 to say 2010, over around 160 years. So you will see that there has been random fluctuations in the rising annual average temperature over the year. I mean, sometime negative and positive both. I mean, you can see here approaching up to zero. But rarely it is going up to zero or slightly positive in the past, up to 1900, say, or 1950, around 1950. But after 1950, you can see that there has been consistently positive anomaly. Anomaly means rise, the deviation from the mean, you can say. And there is only rise in the temperature is only towards positive side. And after 60s, 60s, 70s, if you see, after 70s, these are decades of the 70s, 80s, 90s, and 2000. You can see that there is consistent rise in the temperature. So it means after this industrial era or industrial evolution, man-made activities have contributed significantly in towards the positive anomaly. Over a decade, the temperature is consistently rising. So this is again another alarming situation which has been reported by IPCC in 2013. Now, there are some observations from India Meteorological Department over India. If you talk about the Indian context, you can see that again there has been positive and negative anomaly in the temperature, that during some years, you can see from 1900 to say around 2010, in 110 years, there has been some episodes of cooling. Then, of course, in between, positive anomaly means rise in the temperature, plus and minus. But here you can see after 2000, the decade of 2000 or the beginning of this century, you will not see even a negative, single negative anomaly, or basically lowering of the temperature from the mean value. Even in a single year. So there is consistently, the height of the towers are continuously increasing, and it is approaching to some years up to 1 degree rise. This is average of say around maybe more than 500 stations all over India. India Meteorological Department observation stations. So this is, I mean, a clear sign of global warming. You can see the last few decades. So again, you can see that there have been droughts, floods, and in the past few decades, this is, rarely you are seeing the normal rainfall activities. All India summer monsoon rainfall is starting from 1871 to 2016. There have been floods, droughts, more droughts, and very rarely the normal rain. And even if it is a normal rain, then also it is showing some negative anomaly. Rain is of course at lower side, but then drought years are, of course, after 2003, you can see 2008 is again the drought year. So the extreme activities are increasing in past few decades. So this is the scenario over India. I'll now come to the Himalaya. This is the Himalaya, and a little about Himalaya. So we'll be talking about the temperature trends in the Western Himalaya. Basically, this is Shivalik range. You can see, in the old pictures, if you see, say 100 years ago, these front mountains series was also covered with the snow. But here now you can see only in the highest peaks are snow covered, but the snow cover is retreating basically. And if you see again, as I told you that if we talk about the trends of maximum temperatures, these are also increasing. There have been random fluctuation in the past few decades, or starting from the beginning of this century. But here the trend line shows that after 80 years, the maximum temperature during winter, basically winter temperature are rising up. We are not experiencing that severe winter which used to be there, and which was good for the Himalayan ecosystem. as far as the flora, fauna, and everything, your cryosphere or say hydrological cycle was concerned. But now in the past few decades, you can see the 30-year average. If you see the 30-year sliding temperature trend is consistently going up. Here also, if you see the maximum temperature during January, February is also consistently going up with a slight, fluctuation, and in the in around 2005. But then trend line is slightly increasing, and these are the winter temperatures basically. So summer temperatures are not of that concern, because winter temperatures are of concern because it gives lot of it increases the heating melting rate of the snow and the glaciers and the all sort of the frozen ice or water in the Himalayan region. So this is a alarming situation. Again, if you say standard deviation is even January, February standard deviation, if you see in the winter, so temperature deviation is much. I mean, even the temperature are rising, they are rising by about more than 2.75 degrees Celsius sometimes in winter. Whereas the summer and June, July, August, you can see there is not much deviation. But then, so winter are getting hotter in Himalayan region, which is not good for Himalayan ecosystem at all. Again, if you see here the central Himalayan region, after 2001, as I told that, whenever the surface temperature anomaly is high, and these are towards positive side, the surface temperature are increasing, the rainfall is also decreasing. So this is where direct relation also we can see that with the increasing temperature, rainfall is also decreasing. And if rainfall is decreasing over Himalayan region, be it the western disturbance or the monsoonal rain, so of course the ice content will also reduce, or snow content will also reduce, and that will cause severe implications in future as far as water needs, fresh water needs is, or the river water is concerned. Now this is actually the model projection for the Western Himalayas, taking baseline temperature of 1960 to 1990, and from there under predicting the climate or the temperature. Basically, we can say that this is for maximum temperature over the Himalayan region, and this is Western Himalayan region, and this is minimum temperature for Himalayan region. So if you see that the difference of this is model projection and this is actual. So the actual temperature during 60 to 90 period was this is maximum, this is minimum, and this is model calculated model projections, forecast, or you can say that prediction. So if you take the difference of this predicted and the actual, so by the end of this century, you will be able to see at least minimum 4 degree and maximum 7 to 8 degree rise in the temperature over Himalayan region. So see, this is the J&K Himalayan region and some portion of the Western Himalayan region of Himachal Pradesh, you can see. So the temperatures are definitely going to rise at least 4 to 5 degrees Celsius by the end of this century, which is not a healthy situation for the Himalayan region. If the temperature where it used to be 10 degree, it suddenly becomes 15 degree. So you can imagine that how much snow will be melted and glaciers will disappear. Again, these are the temperature from Himalayan region, one of the entomological station, Mukteshwar. So taking the reference of the Mukteshwar, if you see here, that the temperature, or if you try to draw a mean line here, so temperature will be somewhere between 10 to 12 degrees Celsius maximum temperature, 10 to 12 degrees Celsius over the year over Mukteshwar. But now this temperature by the end of 2010, if you see, it has gone up to say, I mean, the highest fluctuation is around 2006 has gone up to 16 degree. So from 11, 12 to 16, 4 to 5 degree temperature rise has gone up within 100 years. So now in coming another 100 years, if it goes at the same rate, so you can see the impacts of climate change. If the 5 to 6 degree temperature rises, or 4 to 5 degree temperature rises over Mukteshwar or say Nainital in around Pithoragarh region, so it is, what we were seeing the temperature around Kathgodam or Jallikot, you will be having that temperature in Pithoragarh. So these are some of the observations based on the calculations, based on the data, that most of the glaciers in the Himalayan region over the last 50 years, if we see the record of the average of the 57 years up to 99 or some 2010, some of the glaciers where data was available. So more of the glaciers have average, if we take the average, around 18 meter per year. Glaciers are retreating back by 18 meter per year on an average. So again, this is if the glaciers are going back retreating, so white is becoming green, or snouts over the mountains. So this is not a very healthy situation. This is again an alarming situation for Himalayan region. So now these are some of the challenges, and what could be the mitigation strategies for the policymakers. A scientist can just give an input that this is happening, but then ultimately it comes to the execution level where the bureaucrats and the politicians are responsible to execute the policies, and that depends upon completely upon them. And you can see that what the calamities of the recent in Chamoli district, you can see how many lives have been lost, and a power project was completely washed out. So if we are not taking this alarm of the nature seriously, so definitely we are going to lose many things in future. So awareness programs at all levels are compulsory and should be run for all sectors of the society. And then of course the traditional knowledge has to be given values, because there was no science, written science. People by themselves were scientists. Nowadays there are a lot of science available in the closed room, but then the implementations or execution of that science from lab to field is rarely seen. So our traditional knowledge of protecting forests, protecting our all natural wealth was well available with the people since ages, that we learned in our villages. When we grown up in our villages, we used to see such examples in our daily life. But all those things have been completely taken over by the modern practices, and somehow neglected or lost. So those knowledge has to be restored, and make awareness about that also, or propagate further, disseminate in the society. Of course, reducing the combustion and restricting open burning is of nowadays a matter of great concern. In Punjab and Haryana, crop residual burning, there has been a lot of strategies and policies in place for last few years. Then sustainable development we talk about, but then sustainable development for one place may not be applicable to the other. Those things also have been worked out in consultation with the people of the region who have the traditional knowledge on that subject. International conventions and treaties also need to be followed, implemented. National and international funds for environmental protections are required to maintain the to protect the environment in general. New technologies for recycling, which are actually like we talk about the plastic. So plastic is also trying to causing severe damage to the environment, because it takes hundreds of years to decompose, degrade. So these are some of the issues. Then lower the transboundary emissions, because it is again an issue that if some countries are trying to reduce their emissions, so others also need to look into that also at the similar proportion. And more R&D, research and developmental activities on renewable energy sources has to be taken up, not at the cost of the environment. Like we are seeing in the Himalayan valleys, a lot of power projects are being constructed, and which is not good at all for, of course, some of them may not be avoided for energy requirements of such a huge population, but not that we have to consider each and every project as equally important. So ethical approach to avoid exploitation of the natural resources. This is again responsibility of each of us, that to what extent we exploit nature or natural resources. That is should be a sort of a moral part of the moral education, or the ethical approach of our life. Then we need to further, if we want to employ some mitigation strategies as far as the people who are residing in the Himalayan region. there is a severe requirement to work upon the agricultural and allied sectors. I mean, because people are doing traditional farming, of course, but then nowadays that traditional approach no more is that efficient, because we do not have watershed management. There we rivers are flowing just in the down areas of the villages are located higher up, so the irrigations and all those activities cannot be taken up using the water from the rivers. So all these things requires to be worked upon. Soil and water conservation tactics should be implemented or trained. People have to be trained for that. Then inputs, subsidies, support systems from the government are to be provided in order to support the agriculture in the mountains. Organic farming has to be promoted. So there are all these things are in place, but there is not a suitable model that or vertical working model that can attract many people, farmers or unemployed people towards the agriculture sector in the Himalayan region. So this is again a big challenge where we have to, scientifically or with some sort of very working approaches has to be implemented so that people get attracted towards this. And of course, these are some of the activities which can be taken up: horticultural, allied agro horticulture, herbal, medicinal and aromatic plants, etc. So forest and biodiversity also needs to be looked into seriously, because if forests are decreasing, that also contributes lots to the air pollutions and all sort of environmental issues. Natural disaster reduction and relief activities are again an important aspect. Ultimately, if climate change is taking place, environment is degrading, and the implications are visible, so then of course we have to be ready for the natural disasters and how to provide reduction in these disasters and how to support, extend the relief to the people of the region. So this is now a picture from our Aries office. You can see that this is our office located on the top of the mountain called Manora Peak. And this is our administrative block. And this is one facility we call STF radars, stratospheric tropospheric radar, which is used for the measurement of the winds in the vertical. So these are the antennas installed on the rooftop. These are 3-element Yagi-Uda antenna, basically, which radiates power or electromagnetic signal into the atmosphere, which get scattered from the atmospheric echoes. You can say the atmospheric turbulence or sort of atmospheric phenomenon or processes, and we get that backscattered signal. This is inside the building, basically hanged on the roof from below, and on the top of the roof you saw the antenna. These are if I can stop it here just for a moment. These are basically power supplies, and this is transmit receive module. So this generates the signal and sends into the atmosphere and then receives back through this. This is power supply to this instrument. So these are working in coherence. Basically, we call them Doppler beam swinging is generated through this and by giving some phase difference from one unit to the other, and we form a beam and then radiate that power, peak power around 230 kilowatt into the atmosphere. But then only say 4 to 5% of power is taken up into the atmosphere, and then from atmospheric turbulence or say scales of the turbulence, we get the backscattered signal from the atmosphere. Now this is working lab on the rooftop. Again, this is our ground floor where radar controller is kept. These are some radar control systems, component of the radar control system. This is how our backscattered signal looks on the screen of the when radar is working. So you can see the patches green and red around this zero Doppler. So if you see the stronger patches this side, you can say that this is negative frequency, and that is signal is moving, atmosphere is moving away from wind. Basically, it measures the wind. Wind is going away from the radar, and if it is a positive signal, you will see that wind is coming towards radar. So it works on the principle of the Doppler shift. So this was, then there are some more instruments there. Yeah, this is when radar is operating. This is our radar controller. Now I can just move on a little more. Yeah, this is our small another laboratory for mountain meteorology, and we are having the fine particulate sampler also, which gives, this is for PM10, and the previous one was for PM2.5. And we put a filter inside this, and from this pump we suck the air inside it, and then the filter kept inside this instrument that collects the this particulate, and which is basically subjected for weighing and for chemical analysis, that what is the composition of these particles. So there are two different chambers where we can collect both the samples PM10 and PM2.5. So this is the latest one. This is another instrument that we have just received from Japan, and this is even much better instrument. It doesn't use any filter paper. It simply used a device, this device which works on the light emitting diode, and based on the attenuation inside this instrument, based on the attenuation of the light, basically we calculate the particulate matter 2.5. So this is PM 2.5 outdoor unit. We call it compact useful instrument for PM 2.5 QP, PM 2.5 measurement. So we are going to supply one of this unit to Nipari Simant Engineering Institute. I have already discussed with Dr. Negi, so he'll be taking care of this instrument there. So very soon we are going to install this. So we are in the process to do all sort of official formalities, and we'll be able to send this instrument to Nanipari also, so that you can also see every minute or every 5-minute values of the air quality, what is air quality in your institute. So this is very important instrument, and we have received 14 such instruments which we are going to install in all district places of Uttarakhand. So I am leading this project from Aries. And this is how it looks on the screen. You can see here that how the PM 2.5 is behaving. So over the period of the day, you can see that at what time the PM 2.5 values are high, at what time the low, what is the dynamics of the region. So all these things will come into picture. Then another, we have some instruments on this tower also. We have the measurement of the winds, two levels. We have radiation measurement, what solar radiation is coming. You can see here the radiation measurement, and we also have a lidar. This is a small lidar. However, this is not functional nowadays, but then once the laser becomes operational, we'll be getting the vertical profiling of lidars of the atmosphere. Basically, that will detect that how high the air pollution has gone up in the atmosphere. This is detected with the lidar. And this is how you see, in the evening time, atmospheric activities, how the radiation fog forms in the evening and get lifted up in the atmosphere with the horizontal winds, and then suddenly disappears. So these are the beauty of the mountains, and that's why we love to live in the mountains. And of course, you might be seeing such activities in Pithoragarh as well. So that's all from my side, and I would like to thank to all participants for listening me patiently. And now your questions, doubts are to be addressed. Thank you so much for inviting me once again.
Thank you so much, sir, for sharing your views.
Thank you, ma'am.
Participants, is there any query? Sir, we'll mail you further.
Sure.
Yes, sir. So now I'll invite Dr. CMS Negi to say vote of thanks.
थैंक यू सर।
Thank you,
Arun, sir.
Negi ji. I hope the previous session would have also been very good because Dakaji is also very lively and interactive person. So thank you, Negi ji. So I would leave now. Okay, thank you so much.
Okay, welcome, sir. सम्मानित विद्वानजन, अध्यापक एवं छात्र छात्राओं, ननी परी सीमांत इंजीनियरिंग संस्थान पिथौरागढ़ में आयोजित किए गए 2 दिवसीय राष्ट्रीय ऑनलाइन कार्यशाला मिस्ट्रीज ऑफ फिजिक्स के समापन अवसर में डॉक्टर चंद्रमोहन सिंह नेगी संस्थान की ओर से सभी उपस्थित सहयोगी जनों को धन्यवाद प्रेषित करता हूं। मैं सबसे पहले विशेष आभार व्यक्त करना चाहूंगा यूकॉस्ट देहरादून का, जिनके द्वारा यह कार्यक्रम प्रायोजित किया गया। मैं आभार व्यक्त करता हूं निदेशक प्रोफेसर एएस विद्यार्थी जी का, जो कि संस्थान हित में आयोजित किए जाने वाले प्रत्येक कार्यक्रम हेतु अपनी ओर से आगे बढ़कर प्रोत्साहन एवं सहायता हेतु हमेशा तत्पर रहते हैं। साथ ही मैं जिलाधिकारी महोदय पिथौरागढ़ का भी आभार व्यक्त करता हूं। मैं विशेष आभार व्यक्त करना चाहूंगा प्रोफेसर एसके ढाका जी, प्रोफेसर केडी पुरोहित जी एवं वरिष्ठ वैज्ञानिक साइंटिस्ट डॉक्टर नरेंद्र सिंह एरीज नैनीताल का, जिन्होंने अपना बहुमूल्य समय हमें दिया और व्याख्यानों से लाभान्वित किया। मैं अन्य सभी लोगों का, जिन्होंने इस कार्यक्रम में उपस्थित रहते हुए अपना सहयोग किया, उनका धन्यवाद करना चाहता हूं। जैसे डॉक्टर जीएस गड़िया जी, LSM PG कॉलेज पिथौरागढ़, डॉक्टर गुंजन पुरोहित जी, DAV PG कॉलेज देहरादून। कोरोना महामारी के इस दौर में बिना तकनीकी एवं सामूहिक प्रयास के यह कार्यक्रम करना अत्यंत कठिन था, जिस हेतु हमारे संस्थान के कर्मठ एवं बहुमुखी प्रतिभाओं के धनी देवेंद्र गिरी जी, अपूर्वा रवि पांडे जी, पंकज बिष्ट जी, कुंदन जी, तरो महाराज जी, रीना पांडे जी, के गुरुराज जी, तृप्ति कुमार जी का भी विशेष आभार व्यक्त करना चाहता हूँ। और विशेष अनुरोध है कि अपनी ज्ञान एवं ऊर्जा से संस्थान के द्वारा आयोजित अन्य कार्यक्रमों को सफल बनाने हेतु आशीर्वाद प्रदान करते रहेंगे। आपका विशेष आभारी डॉक्टर चंद्रमोहन सिंह नेगी। जय भारत, जय उत्तराखंड।